Please, Bill. I'm Jeannie. We're two do-it-yourselfers who met on a sailboat in 1988. 3 houses and 4 boats later, we're refitting our 1998 Seahorse Oceaneer 55-foot steel trawler, Blue Sky. Welcome to our journey.
When we last were working on the bow thruster, we were seeing really large currents being pulled. We had no way of really measuring it accurately. Since then, I've gotten the probe here. There's the current meter that I've purchased. It has a couple settings. It'll do 10 millivolts per amp or 1 millivolt per amp. And we're going to use it on the 1 scheme. And then that's going to be feeding the oscilloscope down there so we can see how much current we're actually getting before the battery shut off. And the first reading we're going to do is how much current does the bow thruster use. So we'll do a couple samples, and right now I got the meter on the red line, and then I'm switched over to the black line. May switch it earlier because I'm not sure which way this will go on the oscilloscope there. I'm not sure which direction the waveform will go, so that may be reading negative current right now, which means it'll go down. 1, 2, 3, 4, about 600 amps is what I can currently see on that screen. Okay, so that's what we're going to start testing with initially later. Okay, all the circuit breakers are off, the power supplies are off, so it should have only effect on this. So just a half second. I'm trying to figure out what the meter's doing. So just real, over and back.
Okay, here we go. It went red and it turned off the battery.
Yeah, I know. Oh, that didn't click. What clicked? Those are good. Those are both good. I'm trying to figure out what tripped. We did figure out that the second problem we had was caused by this guy right here, which is the circuit breaker. It, for some reason, is no longer properly passing current, so I've put the fuse back in, and as soon as I did that, I was able to get the bow thruster to run. But we still have issues with the battery's BMS dropping out. The bow thruster has a 500 amp fuse, so I thought it was 524, whatever that comes out to, close to 500 amps of current. That's not the case. We actually were able to get a good meter reading on it, and it was showing 782 amps, I believe. Remove the 600 amp breaker that became a load source itself, and we're going to return it. It's still under warranty, but we will not put a new breaker back in. We will just use the old fuse later. Now that we've removed the breaker that was failing and replaced it with the fuse right here, we're going to test a single battery to see how much current is being pulled from it when we operate the bow thruster. So I got several different instruments going. So I got that guy showing the 27 volts, which is charged 24 volt system. Got the meter that will read current every half second to see if it gets any triggers. And then finally, we have the oscilloscope probe right here to read the current coming out of this one battery here, and then it will be displayed up on that screen here. And this is a triggering oscilloscope. Well, they're all triggering, but this is going to do a single trigger. And the yellow line is the 27 volts. The current line is the one above there. Hopefully we will see that one trigger with the current on there. That is the plan, and I'll bring you back in a minute when we're ready to do the test later. Okay, go ahead and turn on the bow thruster.
I turned on the stern battery.
Okay.
Now I'm turning on the bow battery.
Okay, yeah, it came on.
Now I'm turning on the panel.
Okay.
Okay, everything's on.
Okay. Okay, we are in trigger mode.
3, 2, 1.
Cool. Well, we got something. Didn't run for very long though. I mean, it tripped out really quick, but we definitely got some waveforms. Man. Yeah, there it dropped to 0. It's interesting, it's like it took both batteries out. Waiting to see if it'll come back or not. So far, no return. I don't know if I can adjust that after it's triggered. Oh, yeah, I can. Was that the actual current all the way up there? Yeah, definitely on the down cycle. Yeah, it's just weird where that triggered. I need to figure out how to make it show more data. Is that my full amount? I gotta figure out what that is. Okay, anyway, we have some data to look at later. Whenever you're ready.
All right, 3, 2, 1.
Yeah, I know. It went for a while. Cool. Okay, I didn't get a trigger though because the voltage never dropped out. Well, it did trigger. Okay, so you're gonna do the opposite of what you just did. You're gonna go to starboard, I believe.
3, 2, 1. 1001.
Tough.
And it went right away.
Yeah. Well, it's interesting. It came back this time. I'm reading back at 27. Even though it went instantly, it didn't stay off. Man, we got a big current spike there. I think we should go for a walk.
We don't have that much water coming out of the end thing because of our...
Oh, right. Yeah, it's coming out on the side there. Yeah, we need to get the gutter stuff put up on those. So many things we need to do. Right now, the bow thruster appears to work correctly in one direction, or at least it doesn't trip the batteries right away. But as soon as you try to go to starboard with it, it shuts off very, very quickly. And so we're thinking that there could be something wrong with the solenoid, which is the big relay device that controls the high current for the bow thruster. That solenoid is behind this plastic cover there, so I'm going to remove that, take the wires and everything off of it, then take it out and take the solenoid apart to see if it is welded itself together or the springs that would normally cause it to come apart have failed or something. And we'll see if it's either repairable or we'll get a new one on order. That is the solenoid right there. You got two big coils here. Does that whole thing have to come out? And one of the reasons we don't think there's an issue with something in the chamber is I can spin this pretty easily. No real resistance. One solenoid removed and a whole mess of wires going every which way. Take it apart now. Later. Got the solenoid apart. The contacts were not stuck or anything, although I do see quite a bit of carbonization on the pads on at least the top. Both of these.
Show me the carbonization.
That's this little dark spot. That makes a little bit of sense because the way this works is one stays down and stays in contact, so it doesn't have to move anywhere, and then the other one bounces up to reverse it. So, you know, going one way you get this, and the other one you get this. So these guys are just doing this. Well, maybe it actually has to do both.
What is the purpose of a solenoid?
It carries the high current. It's what switches the super high current. I want to clean these off, and then I want to take it back down there and apply 24 volts with clippers on each side to hear each side trip. Oh yeah, there's quite a bit of arcing inside of there too. You can see the carbonization on those contacts. Clean all that off.
What do you clean it with?
If it was just the carbon buildup, you could use an eraser, but this has actually pitted it some. So I'm going to have to get a Dremel wheel or something, some little bit of sandpaper that can get up in there and clean this off. Okay, we have cleaned all of the surfaces now. You see there on both sides they're nice and clean. Used the Dremel tool to get the heavy part off, then came back with some 400 grit sandpaper. And now I'm just going to apply a super thin layer of dielectric grease, all of these, hopefully to assist in making a contact and keeping carbonizing from occurring as quickly, promoting a better contact. So there are the contacts back in on the lower plate. And this whole assembly to go back together with the springs in place. The springies go there. Okay.
And then the next thing we're going to do is put it back in.
Yep. Okay, so we got the solenoid all back together. What I'm doing right now is I'm making sure these solenoids are good. I want to make sure we get a good contact. So I'm going to apply voltage to this solenoid right here. So I got the negative over here. I'm going to put the positive on right there. This solenoid should click, which should cause the contact in this part of the solenoid to put these two things together. And when they go together, we should get that. A nice tone. So let's see. Of course, now I got to move this out a little further. Yep. So that side is working well. So now what I'm going to do is I'm going to switch this to the other side, unclip this, clip it there. Then we're going to try this side, and now the two on this side should become connected. Yep. Okay, so the solenoid seems to be completely working. I'm getting a 0 ohm reading, which is always a good thing. So hopefully there is no issue with the solenoid now, except it's not installed. So that is the next thing I will do. Attempt to put this back into the housing here. We got everybody disconnected at the moment. Yeah, and I just want a 1 second burst to port first, see if it still runs, and then we'll flip it and see how long it goes to starboard.
3, 2, 1.
I heard it clunk, but it didn't do anything. Did you?
Well, it moved. It didn't turn off.
I just didn't even see the thing start rolling. Hang on, let me get my glasses on. I didn't even see the motor run. Okay, I'm watching it closer now. Do the port one more time.
3, 2, 1. I think that blew it.
It didn't roll or move.
Battery's back on, panel's back on.
Great, so now we can't even go to port anymore. At least we could go to port a little while ago. All those breakers are in place. Turn the panel off and then turn the battery
Panel's
off.
off.
Okay.
Bow
Okay.
battery's off. Stern battery's off.
Okay. Turn them both on. I want you to go to port again.
3, 2, 1.
Okay. Ran that time. Now go to starboard.
3, 2, 1. And it blew.
Yeah, but you're doing it long. It seems like longer than 1 second. Well, at least it's running both directions now. Now we need to do all the current measurements and confirm that we need to add 2 more batteries. That seems to have fixed all the running issues. And now I just want to confirm what's the current like coming out of the batteries, what's the current going into the motor. We could possibly have issues with the 4 breakers we have on each battery. They could be limiting current or causing extra current to be pulled. But until we get the meter set up and do measurements on everybody, I don't know, and I'm not going to do that right now. Shut everything down. Put the cover back on here. To summarize, where are we at? We are able to make the bow thruster run for 1 or 2 seconds in either direction. So the solenoid, dirty solenoid, was definitely the issue with going to starboard. But now we need to do current measurements on the bow thruster, confirm what it's pulling, and then also do it on the individual battery banks, then on the individual batteries. I'm suspicious that these little breakers I added are causing me a problem. I may take the breakers just totally out of the circuit to make sure they're not my issue. If we finally confirm that we need a 3rd battery, then 1 battery would go up there and 1 battery would get dropped in right there. The bow thruster battery replacement saga goes on. My recommendation right now, until you can get some lithium batteries that have a 500 or 600 amp BMS, don't try doing this. This has been a pain in the rear. Later.